Hi folks, here we go. All right, we're going to get used to how we use the algebra to solve a triangle or to find missing components of a triangle using the sine law. Lots of fun here. Okay, so let's see what we've got to do with this one. So we're going to use the sine law first of all to find missing sides, and then we're going to use the sine law to find missing angles, and then we're not going to use the sine law anymore because that's pretty much all it does. Okay, so first of all, let's look at an example of finding a missing side. First thing we have to do is label up our diagram. So we've got a diagram here. We're going to pick names for all the sides and angles. So A, B, C are three good ones that we're used to. And so remember, opposite angle A has to be side A, opposite angle B has to be side B, and opposite angle C has to be side C. Okay, so from there we've got to check to make sure that we have the right pattern in this triangle with the things we know and the things we don't to use the sine law. So first of all, we need a pair of known opposites, which we have with the B's, and then we need to have the thing opposite the thing we're looking for. So we know that side A, which in this case is our X, is directly opposite angle A, 55 degrees. So we have two pairs of opposites with one unknown component, so we're good there. So there's our pattern. Now we set up the equation. So we're using A's and B's here, looking for a side. So we're going to say A over sine A, and this is probably the most common way that you see the sine law written, equals B over the sine of angle B. Okay, so we're just going to take that little equation and we're going to fill in the details for this example. So A over sine A is going to be X over sine 55, because that's what A and A are in our triangle. And then B over sine B is going to be 11 over sine 75. Okay, and that's what the sine law tells us. Everything else from there is just algebra. So the first thing we have to do is isolate X. So to isolate X, I'm going to talk about cross multiplying here. So I want X times sine 75 and 11 sine 55. So we have X multiplied by the sine of 75 degrees, which is a number unto itself. I can't take the X and multiply it just by the 75 inside the sine or anything like that. This 75 is locked inside there. Same on the other side. I've got 11 sine 55. And I can't get that 11 inside those brackets at all. It's stuck out in front of the sine, as we say. Then to get X by itself, I'll simply divide by the sine of 75 degrees. I'm dividing both sides here by sine 75. And we eat these sine 75s over here. So X is actually equal to 11 sine 55 divided by sine 75. And all that's left to do with this now is ask our handy, that's a 75 should be, ask our handy dandy calculator what the answer is. So if we take 11 sine, you can hear my clicking buttons in the background, I'm sure, 11 sine 55 divided by the sine of 75 is going to give us a magical answer of 9.3. So what we've got here is roughly, I rounded off a little bit, 9.3 units of measure, whatever they would happen to be in this example. It wasn't specified. Okay, so that's how we find a missing side using the sine law. Now we have to look at how we find a missing angle using the sine law. So same steps to start off with. Always label your diagram first. So we've got an A and an A. And I guess we can call this one angle B, making this side B down here. And then angle C and side C over here. So that's done. Now we check our pattern. We've got theta, and we do know its opposite. And then we need a pair of known opposites to get us going, and we've got that with the B's. So in this case, when I set up my sine law, I'm going to set it up to say sine of A over A, kind of the upside down of what we did in the last case. So when you're finding a missing angle, this is just sort of the easier version of the sine law to use. So sine A over A equals sine B over B, and I'll fill in some details. So this will say sine theta over length of side A, which is 4.3, equals sine B, which is sine 38 degrees, divided by 2.8. And so we've set up the equation, and the only thing we don't know in that equation is the value of theta. So let's see if we can get it. Next it says to isolate sine theta. Okay, so again, we just use our cross multiply trick. So up to this point, it's more or less all the same stuff, except for the fact that our equation is upside down. Everything looks kind of like it did when we were looking for a missing side. But after this, it gets a little bit different. So we got 4.3 times the sine of 38. And remember, I can't multiply any of this stuff together on either side here because what's inside the sine stays inside the sine until it's evaluated. So divide both sides by 2.8. And when I do that, I'm going to have sine theta all by itself, which is what we were supposed to isolate. So now I have sine theta equals 4.3 times the sine of 38, all divided by the sine of, 2.8 is what it was. Okay, so there's two steps to finish this one off, which makes it a little different from when we're finding a side. First, we evaluate the expression, but that won't tell us an answer, or at least a final answer yet anyway. It'll just tell us what sine theta is. So I want to take 4.3 times the sine of 38, and then I want to divide that by 2.8, and that's going to tell me 0.945. Now I'm going to write down 4 decimal places. It's important with trig ratios, since they're so small anyway, they're always less than 1 for sine and cosine, that we write out lots of decimal places. So I've got 0.9455 for this one. And then to get angle theta all by itself, I have to use the inverse sine. And this is my last step. So inverse sine of that number, 0.9455. And you're probably, many of you used to just saying going from here in this step when you were in grade 10 to telling what angle theta is. You don't have to write it out this way if you don't want, but it's a common thing to do as well. So just to show that I'm using inverse sine here, that's what I'm doing in my calculator. So inverse sine of 0.9455 is going to be about 70.9967 degrees. I'm going to call that pretty darn close to 71 degrees. So we've got an angle of 71 degrees right over here in our triangle. That was our missing angle theta. All right, so that's it. That's how we use the sine law to find missing sides and angles. So it's pretty much the same thing. Label the diagram, check to make sure we're using the right law, set up the equation, and that's the same for both, whether you're doing a side or an angle, and then you just isolate what you need, evaluate, and then if you're doing the finding an angle business, make sure you use that inverse sine to finish it all off. And that's it. Thanks.